How do you do, ladies and gentlemen, and teachers and boys and girls? I am Julia Sumner Miller, and physics is my business. And today, some very special business entitled Adventures in Electromagnetism. I hope you have detected in the several programs we have presented, produced, my phrase, my word, adventures. That's what these must be, how these must be viewed. They are intellectual adventures filled with drama and good for the spirit and the soul. So what do we have? Oh, before I get on it, I had on my lecture table here at an earlier hour a beaker with some copper sulfate solution in it. Some hours had elapsed, and there must certainly have been some crystals already in the solution, but they were added to by the deposition of atoms, millions upon millions, giving us a crystal of this beautiful geometry and design and color. And I am always led to ask, how do the atoms know where to go? How do they know where to go in order to form the crystal of such and such a shape or geometry? But regarding electromagnetism, supposing I had an iron ring, like a donut made of iron, and I put a coil of wire around one edge of it, and another coil around the other. And this is exactly what Michael Faraday did with an anchor ring, that is a link of chain from an anchor chain. And what did he do? He gave rise, by connecting to some seat of electrical energy, he gave rise to a current in this coil. On this side, he had a detecting instrument, which I will call a galvanometer. And a strange and wonderful thing happened. When he closed the circuit on this wire, on this coil, the needle showed a deflection over there, and no physical connection between this coil and that one. And this was the beginning of the transformer. I have such a thing as Faraday might have used. Here is an iron ring like a donut, and there is a coil of wire, and there is another coil of wire, and they are not connected with each other. This one I have connected its ends to a detection instrument, a galvanometer. And by the way, I'm reminded to tell you, Faraday needed some insulated wire. And how do you suppose he got the insulation? He tore off strips from his wife's petticoats and wrapped the wire, and thus insulated it. Isn't that enchanting to think about? Now, I am going to connect the one coil to the ends of the terminals of this battery. And watch what happens when I do that. Watch the needle now. Whoa! So, on the make, we have a deflection in one direction. When the circuit is kept closed, the current is steady, but it is a change of current which gives rise to a changing magnetic field, which gives rise to induction felt by the other coil. If this is the one I energize, we usually call this the primary, and this is the secondary. But I could turn them around and interchange their names. A little more of the same, which is very exciting. Here is a coil of wire of so many turns. Here is another coil of wire of so many turns. I am going to put this coil inside of that one, and the degree to which they are coalesced, let us say, we call the coupling. Now, I am going to connect the outer coil to this meter, and then I am going to connect the inner coil momentarily to the battery. And you watch the needle. Watch it now. I'll come over this way. Watch. The deflection is feeble. The coupling is very poor. The induction is not so good. Let me increase the coupling by having the inner one more inside the outer one. Now watch. Oh, I'm having a little trouble there. A little more deflection. Let me couple them completely. A little more deflection. Now you will observe that these are air cores. That is, the central place in here is empty of any magnetic stuff. So what am I going to do? I am going to put an iron rod, which is a big, heavy 80-penny nail. I am going to put that inside the inner coil. Now I'm going to connect the circuit momentarily. Watch it now. Watch. Oh, look at that. So you see why it is that a transformer, which may be viewed as one coil and another coil, has best or works best with an iron core. Electromagnetic induction. And to whom are we indebted for this? Michael Faraday. Now, consider this enchanting business. Here is a coil of wire of so many turns, wound in a certain direction. I have the coil connected to a zero-centered meter. Here is the pole of a magnet. Watch it. Deflection to the left, deflection to the right, deflection to the left, deflection to the right. Now I'm going to connect to the other coil. Deflection to the right, deflection to the left, twice as much. Answer, twice as many turns on this coil as on this one. If now I put one pole of a magnet in this one and one pole of a magnet, the other pole of the magnet in that one, we find an interesting thing. Watch it. You see that the EMFs, the electromotive forces, add. Now let me go to another coil, this one. Watch it. Whoop. 3 or so to my, your left. 4 probably. Let me turn around the magnet. Now let me go to the next coil. Watch it. Turn the magnet around. Now let me see how the EMFs behave when put together jointly. Watch it. This suggests what? This coil has the same number of turns as this one, and they are wound in opposite directions, so the insertion of the North Pole here gives rise to an EMF with a current in a certain direction, and this one annuls it. So the effect is 0, practically. Now let me go to the 2 last ones. Watch it. 3, 3. Change the magnet. 3, 3. Now let me go to the outermost coil. 3, 3. 3, 3. Now let me see how the EMFs add. Watch it. If the scale were big enough, it would go to 6. So this suggests at once how these coils are wound. Now consider the following. Supposing I had a bar of magnetic stuff like iron, and I wrapped a few turns of heavy wire around it, and I connected this to some difference of potential like a storage battery, I would have a current in that winding. That current in the winding gives rise to a magnetic field. Supposing now I had another winding insulated from the first, which I shall call the primary, and this secondary winding of many, many thousands of turns of fine wire. The current in the primary heavy winding would give rise to induction in the secondary winding, and if I had the secondary terminals separated in some such manner, I would have an enormous difference of potential. I'm going to show you how high it could be. Here I have a 6-volt battery, 6 volts between here and there. Here I have such an induction coil. I am connecting the battery to the primary of this coil, and the secondary is shown by this gap here between the 2 terminals. Watch it. Now somebody says, what's the potential difference there, Professor? I would say it's 40 or 50,000 volts, 40 or 50,000. Yeah. Now that's pretty heavy stuff. Well, let's look at this one. Here in this box, I have such a bar, which is laminated in order to reduce hysteresis effects, minimize the heating. There is a heavy coil of wire around the primary, which I energize with the storage battery. Here are the terminals of the secondary, right there. And with this instrument, what can I get? Well, watch it. I'm going to connect this one there. There we are. Look at here. Oh, mamma mia. In dry air, the difference of potential is about 30,000 volts per centimeter. And remember, there are 2.5 centimeters in an inch. So I have a couple 100,000 volts there. And you see a wonderful thing taking place, some sparking. And as I like to ask my students and colleagues, what is it that we see when we see a spark? And what do we hear when we hear the sound? And why is the light that we see high in the blue? What I'm getting at, people, boys and girls and teachers, is this, that when we witness a phenomenon so quickly disposed of as I have disposed of this, there must arise many, many questions of a penetrating sort. So I'll say again, why do we hear some sound? Why is the light blue? Further than that, I detect, I smell something. So you see what my senses are revealing to me. My auditory sense revealing the sound, the optical sense revealing the light, and my olfactory sense revealing some odor. As a matter of fact, it's very pleasant. What is it? Ozone. Ozone is being produced. Ozone is being produced by that electric discharge in air, and that has enormous consequence for the human race, because when we have a lightning storm and there is great sparking between clouds and earth, ozone is produced in abundance, and this has some virtue for humankind. So we have explored in a passing and rather superficial way these things which I call adventures in electromagnetism, and I thank you for watching.